Yeah, let's do this in class only. Then subsequent questions we can skip. But first question though is straightforward, yeah. It's an oral question, 5-second question. So your answer to first part is 4 to the power 364. That's correct. First though is straightforward. Letters are different. Boxes are also different, right? Also see, if you want to check it, you can always do it. See, I have 4 letter boxes, right? And you have 3 letters and 4 letter boxes. Okay. Now, question number 2, all letters are different and boxes are same. Okay. Okay. Chalo, cool. So, abhi answer to the first part will be 3 to the power 4. Same, whatever you guys were doing. 4 to the power 3 ki jagah 3 to the power 4 ho jayega, because first letter can go in 3 letter boxes, second letter can also go in 3 letter boxes, and so on and so forth. Right? Now, because you have 3 letter boxes, say letter box number A, B, and C, right? So what all could be the possible number of ways? Either grouping could be 4 in one, 0, 0 in others, or it could be 3, 1, 0, or it could be 2, 2, 0, or it could be 2, 1, 1. Is there any other possibility here that we're missing out on? No. Cool. So yes, answers again would change because I think you guys tried something else. I'm trying something else here. So yeah, fair. These are the 4 cases. Now again, the first part is straightforward, 3 to the power 4. You can again go and check it, because even when you do it like this, like in how many ways can you do it? So for example, if you have to solve the first part using this, again you can do this, because you will say the 4C4, you have 4 letters. So all the letters go into one particular box and then the other can be shuffled, right? So you'll just shuffle them 3 factorial by 2 factorial number of ways and then start counting individually. Maybe I'll give this to you guys as a homework. So what you need to do is, first mein abhi to humne directly kiya, right? 3 to the power 4. Now what you need to do is, you need to also prove it ki even if you select and arrange using these subjective method, you get your answer as 81. So please go and do this as a homework and maybe ask me in the next class. But this will clear a lot of your doubts. This will also help you gain confidence. Ki yaar, 81 ka answer that is coming directly is also same only, right? So now, at least part number 2, same, right? This case that we have made, all the letters are different and boxes are same. So can anyone tell me if I have to put 400, right? See, 400 is what? You select all the 4, right? So it is nothing but 4C4. Like second part is what? 4C4. And then once you have selected 4C4, you can put it in any of the block, because letter boxes are same. You like, it doesn't matter whether you sort of put it in A, B, or C, it's all same, right? So the answer to the first part will be 1, which is 4C4. Similarly, part 2 kya hoga? 311, right? So it is essentially, you just select, because letters are different, right? So which 3 do you select? And then the remaining one is 1C1. That's all. And then you can put it in any 2 blocks. Doesn't matter, because letter boxes are same. Similarly, for 2-2, you select 2 into 2C2. But then the only catch here is, see, 4C2 into 2C2 is what? For example, you've had 2 letter boxes, right? 1, 2, 3, 4. So 4C2 is, you select 1, 2, then 1, 3, then 1, 4, then 2, 3, then 2, 4, and then 3, 4, right? These are like different ways. But because you have to essentially put them in different boxes, right? So whether you select 1, 2, or you select 3, 4, it is essentially same thing, right? Because again, you have to just put them in similar boxes. So whether you select the first 2 or the last 2, it is same, because the last 2 get selected by default. So the only catch here is, you have to divide this by 2 factorial. Why 2 factorial? Because these are like similar groups of 2 and 2, right? So whatsoever you form as a group, the other group automatically gets formed. Hence this. Now with the same concept, if I apply this in the last part, what is this? 4C2, I've selected 2. Then the remaining 2, I will just select any one. And then once I've selected the one, the other one gets selected automatically, right? So again, because here also you have 1 and 1, you will have to divide this by 2 factorial. With the similar logic that we just checked in the last part. Yeah, I think that's it. Then you just solve it, you will get answer as 14. Explained, right? So for example, see, whenever you have to group equal number of things, right? So for example, you select 2 and 2. So you have 4 letters, 1, 2, 3, 4. You have to put them in boxes, say A and B, such that 2 goes in A and 2 goes in B. Then the number of ways is not 4C2, but it has to be divided by 2 factorial because these are like similar boxes, right? So for example, this is A and A. So what you do is you select 1, 2, the other 2 get selected by default, right? So 4C2 will include those cases as well. 4C2 is what? 1, 2, 1, 3, 1, 4. Now 4C2 also includes this 2, 3, 2, 4, and 3, 4. Now essentially see 1, 2 case and 3, 4 case is same, right? Because if you select 1, 2, the other 3, 4 gets selected by default. And because this is a duplication, you will have to divide it by 2 factorial. Hence, as a thumb rule, what you can remember is whenever there are like equal numbers that you're trying to put in similar boxes, you just divide it by that total number of similar things. Hence, divide by 2 factorial.
Okay.
If boxes are different, then you put 1, 2 in box A versus you put 3, 4 in box A. These two are different cases. With similar logic, the part third is also similar, right? Boxes are different and letters are same, which means 4C4, 4C3, 4C1, all of this goes away, right? All of this is nothing but 1 now because you sort of select any 3, you sort of select any 2. It's all same because letters are same now, right? Letters are all same. But because boxes are different, you will have to arrange them, right? So for example, this is what? The answer to first part will be 3 factorial by 2 factorial because in which box you put 4 letters is now going to matter. So this is 3 factorial by 2 factorial. This is 3 factorial. This is again 3 factorial by 2 factorial. And this is again 3 factorial by 2 factorial. Right? I don't have to select because because letters are same. But because boxes are different, I will just have to arrange them. And then you just sum all of them. The answer comes out to be 15. Sum of all of these. Third part clear हुआ कि why did I not do 4C2, 4C3? I only did the arrangement. See, sorry, letters are same and boxes are same. अब कैसे करेंगे? Which means ये भी अब 1 हो जाएगा, right? You can't arrange, you can't select. The only thing you can do is group, which means first इसके भी एक case होगा, इसका भी एक होगा, इसका भी एक, इसका भी एक. The total cases could be only 4. Because you can't select and because boxes are also same, it doesn't matter. You put 4. So the only number of ways will be the number of distinct groupings, which is this. So the answer to the fourth part will be 4. This was one question that explains everything. How do you group? How do you arrange similar things? How do you select similar things? So hence all the 4 parts solving together clears a lot of doubts and it's all conceptual, right? You can't arrange because it's the same. So always just try to go by first principle in PNC. Yeah, always take numbers. Wherever that is identical, consider it as AA and then you'll start thinking by yourself. Okay? ये वाला question कर लो जल्दी. ठीक है. By the way, yes, in this question, like you can assume marbles are identical, but like as a thumb rule, at least for cat, unless mentioned in the question, do not assume things to be identical. Okay? So by default, assume that things are different only. Marbles, it could be different, right? 4 marbles are there. So unless it is given in the question, do not assume it as identical. But yes, if we assume it as an identical, then your answers are correct. It has to be 3 only. Abhi, there are different PNCs, right? In the last question also we discussed key similar things going into distinct items, similar letters going into distinct letter boxes, distinct letters going into similar letter boxes and all. So now we'll try to go deep dive into individual concepts, and we'll start with similar to distinct. So here, so essentially, say for example, there are like 3 dairy milks, right? I want to give 3 dairy milks to 5 different people. Right? So one case is something that we just studied. We'll try to make cases and do it. But then there is a shorter way to solve such questions, and that we'll discuss here. So when n items are not distinct and it needs to be given to R people, say for example, there are n chocolates and I want to distribute it to R person, right? Then the number of ways in which this can be done is this. Again, don't worry about this. Let me simplify this thing. What is this? Again, you don't have to remember both of it. Let's take a very simple example. Okay. Let's consider there are 3 people, and please pay attention here. It is more important than this formula. This is just for the sake of completion, but then don't focus here. For example, there are say 5 people, A, B, C plus D plus E, right? There are 5 people, A, B, C, D, and E. And question is, in how many ways can you distribute 8 chocolates, and these chocolates are same. Say for example, you have 8 dairy milks. In how many ways can you distribute 8 dairy milks to these 5 friends such that there is no restriction, right? Which means any person can receive either 0 or 1 or 2 or 3 or X number of chocolates, right? If there are questions like this, then what do? You know for a fact that whatever number of chocolates A gets or B gets or C gets or D gets or E gets, summation of all of it has to be equals to 8, because in total there are 8 chocolates only which I have to distribute. So whenever there is an equation of this form, right? A plus D plus C plus D plus E, such that all the variables, right? All the variables is nothing but greater than equals to 0, right? Because anyone can have 0, anyone can have 1, 2, 3, 4, 5, 6, 7, 8. There is no constraint at all that this guy has to has minimum 1 or 2 or 3. So whenever you have such question and you have to find the total number of solutions of this, the direct formula for this is whatever is this term. This is 8, right? So you write this as 8 plus, find the number of plus signs here. 1, 2, 3, 4. There are 4 plus signs, right? 8 plus 4, C4 is your direct answer. Right? The answer is 12C4. Again, what I have written here is nothing but what I'm trying to do here is I'll count that, okay, in total there are 5 variables. So instead of 4, I'll write it as 5 minus 1. And here also I'll write it as 5 minus 1, which is nothing but this is n. R is 5, so n plus r minus 1, CR minus 1 becomes my direct formula. And this is a very fruitful formula and we'll solve a lot of questions using this. But again, I'm reiterating myself, where does this work? This only and only works when all the variables are greater than equals to 0, which means they can even be 0. Okay, and you can apply a similar formula in your number system as well. Whenever we have to solve number of cases and all, right? Even there you can apply this. So if you have to count all of this, this is nothing but this gets 8, right? 0, 0, 0 plus anyone can get 8, right? Similarly 7, 1, right? Similarly 6, 2, 6, 1, 1, 5, 3, 5, 2, 1, 5, 1, 1, 1. So all of these cases in total, and you directly solve it using this, because whatever we have learned earlier is okay whenever number of cases are short, like 3 letter boxes, 4, it's doable. But when it increases to 6, 7, 8, then forming those cases manually becomes very difficult, and hence this formula comes handy. Is this clear, everyone? And do we apply this formula? How do we apply this formula? Okay. So similarly, in such questions, you can also have a lot of constraints. So I'll just cover that entire concept first, and then we'll go. 5 friends want to distribute 8 chocolates such that the first 3 guys, A, B, and C, receives at least 1. Right? Now, how do we apply this concept? Because now this constraint is that A has to be greater than equals to 1. This has to be greater than equals to 1. This has to be greater than 1. D and E can be greater than 0 and greater than 0. So I can't directly apply 12C4 formula here because there is some constraint here. So the best method to sort of conceptually think it as whatever is that minimum foundation, A can has to be greater than equals to 1, right? So by default, give one chocolate to A. By default, give one chocolate to B. By default, give one chocolate to C. So if you give that minimum that is needed, 3 chocolates are already gone, right? So remaining chocolate is 8 minus 3, which is 5. And the 5 needs to be again distributed within 5 such that now A can be greater than 0, B can be greater than 0, and C can be greater than 0 because you have already given 1. So if you want to mathematically write this, you will write this as A is equals to A prime plus 1, because whatever was the minimum number of chocolates you have already given. Earlier A was greater than equals to 1. This implies A prime is greater than equals to 0. So the new equation becomes A prime plus B prime plus C prime plus D plus E is equals to 5. Now you can apply that formula and the answer is 90. Everyone clear? How do we solve questions wherever there is some constraint? Perfect. So with this, let's just solve this question. In how many ways can you distribute 5 similar chocolates to 3 friends? Please do not take more than 10 seconds. And even think orally. Step number 1, form the equation. And step number 2, write the direct answer. So the expression here will be A plus B plus C is equals to 5. Answer will be, there are 2 plus signs, right? So the answer will be 5 plus 2, C2. 7C2 is the answer, 21. Absolutely correct, guys. Very good. 21 is the right answer. Everyone clear with this? And if you have to do, see, I'm not just saying for the sake of saying it. Even if you have to solve it manually, cases will be what? 500, 410. बताओ एक और सारे 320, 311, 221. Right? These are the only 5 cases, correct? Now chocolate are same, which means selection mein there is no number of cases, right? Selecting 4, there is no 5C4 because chocolates are same. I only have to arrange them. What is this? 3 factorial by 2 factorial, 3 factorial, 3 factorial, 3 factorial by 2 factorial, and 3 factorial by 2 factorial, right? I can write this as 3 factorial. 6 3s are 18. And this is 3. 18 plus 3 again, 21 is the answer. Clear? It's the same, whatever method you use, but this will take you extra seconds. And the first one will give you a direct answer. Again, oral question, 5 seconds. Good. 12C2 is the right answer, guys. Awesome. A plus B plus C is equals to 10. There is no constraint. So 10 plus 2C2, 12C2. Fix all this. See, you can't afford to make any mistakes here through. Choti si galti kar di in such questions, it's a very big loss. Right? Simple question. There is some constraint because A, B, C has to be greater than equals to 1. So you give minimum 1. Isko ek de do, isko ek de do, isko ek de do. If you give minimum 1, which means ab bachi kitni? Earlier you had 10 chocolates to be distributed. You have already given 1, 1, 1. The leftover is 7. So now the new equation is A plus B plus C is equals to 7. Answer is 9C2. Perfect. And guys, there are 10-15 questions. Let's just solve it in like 10 minutes. Less than 1 minute per question. At most 10 variables. Let's see who can solve this. It's all common sense. It's all jugaad. You have to figure out a way on how do you write this in our form. By adding, subtracting variables, bringing in new variables wherever required. Get to our expression and then write the answer. 20 seconds for this. Let's see. Chalo solve karte hain. Who can tell me? Upal, chalo, batao. How did you solve it? Okay, let me ask Raman. Batao, what is the expression?
मैंने इसको ऐसे किया कि 1 1 1 एक बारी के लिए.
नहीं, सबसे पहला एक्सप्रेशन बताओ. ये क्वेश्चन क्या लिखा हुआ है? पहले वो बताओ.
A plus B plus C less than equal to 10.
A plus, can you distribute at most 10 variables? तो ज्यादा से ज्यादा 10 हो सकते हैं, which means it has to be less than equals to 10. Very good. अब बताओ. Such that each boy gets at least 1. तो सबसे पहले एक एक दे दिया होगा.
111.
अच्छा, हाँ बताओ.
Then 211 ऐसे करके किया है.
केसेस बना रहे हो तुम इस क्वेश्चन में? क्या आंसर है? आंसर क्या आया फिर?
अभी तो किया है ना सर, इसको पूरा आगे तक काफी लंबा जाएगा ये।
बट मतलब why would you then even attempt this question CAT में? तो छोड़ देना है सब तो, cases में आया तो. But then like why are you doing it? Like what is that form that you know? You have to bring it in a form जहाँ पे सारे sum is equals to something, right?
ओके।
तो पहले, is there any constraint here? Yes, there is a constraint that each of them has to get at least one. So first of all, give at least one to them. So the new number is 7, right? 7 marbles need to be distributed. Now, Raman, how do you bring this into equality form? Just think. See, these are some positive numbers, right?
यस।
So Raman, sum of 3 positive numbers is less than equals to 7. So how, and you have to convert this less than equals to equality, right? Which means you have to,
प्लस के
sorry,
ए प्लस बी प्लस सी प्लस के इक्वल्स टू 7।
very good. Which, because this is less than equals to 7, you just add some variable here, which is some non-negative. It could be anything 0, 1, 2, 3, 4, 5, 6, 7. It could be anything. But you try to add some variable here so that it becomes equals to, right? And now k is greater than equals to 0. A, B, C is also greater than equals to 0. So answer क्या हो गया? 10C3. There are 3 plus signs.
ओके।
Sorry.
हाँ ओके सर, अंडर।
Got it, right? So answer to this question is, guys, 10C3. Simple. So our learning here was whenever there is a less than equals to sign, you always add a dummy variable. Now this dummy variable could be anything, right? It is always greater than equals to 0 is what we need. So if you add any non-negative number here on the left hand side, this becomes your expression, and then you just write the final answer 10C3, because 10C3 will have all the values of A, B, C which is possible. If this is clear, let's solve this one. Oral question. No one will use pen and paper to solve this. Give me an oral answer. Good. Answer is 13C3. Minimum दे दो. 4 plus 3 plus 2 plus 1. 10 दे दिया. बची कितनी? 20 minus 10 is 10. So 10 plus 3 is 3. 13C3 is the answer. Solve this one. Very simple. Please solve it orally only, guys. Don't use pen and paper. What do you mean by natural numbers? Natural number is A greater than equals to 1, B greater than equals to 1, C greater than equals to 1. So give the minimum numbers 1, 1, 1. The leftover is 27. Answer is 29C2. Let's solve this one. Again, please try to do it orally. Rohit, Muskan, Dhruv, good. Sheetal, okay. Time up. Dhruv, can you explain?
Yeah, so A should be greater than 25. So given the value of A as like 25, so like 100 will be subtracted, like making the condition A greater than 0. So applying the formula 50 plus 3C3.
But can you apply the formula here? Dhruv, look at the equation again. When is the formula applicable, Dhruv?
N is greater than 0.
No.
Like
What is that?
greater than or
No. That is the variable. But what is the equation?
less than equal to. Got it. Sorry.
There is a less than equals to sign, right? Muskan, Rohit. You can't apply that formula. So you'll have to add one dummy variable, say k, which is again greater than equals to 0, and then apply it. So answer will be, how many plus signs are there? 1, 2, 3, 4 plus signs. Answer will be 54C4. Perfect. Everyone clear? Majority of you have answered it wrong, except 2-3 students. See, in such simple questions, if you make mistakes, you will regret a lot for your lifetime. So make sure you don't do any silly mistakes here. Question जितने simple है उतने tricky भी है. Right? Chalo. Just because you want to attempt, jaldi, don't make mistakes, guys. Please read the question. यहाँ गलती करोगे then इतनी पढ़ाई लिखाई सब waste है. Take 5 more seconds. That's absolutely fine. Don't make any mistakes. Cool. Answer is 11C4. Anyone has any doubts here? Clear सबको? Yes, no? Then let's move on to the next question. Please try this. In how many ways can A, B, and C get 15 chocolates such that C always gets a multiple of 3? Now there is some variation, some constraints here, right? So you'll not be able to apply it very directly. A plus B plus C is equals to 15, such that C always gets in multiple of 3. So what all are the possible values of C? And anyone tell me? C की क्या value होगी? People, how did you do it? People, why
So
can't
I have
C be equal
done.
to 0? Why can't
So
C be
I have
0?
done. So because 0 is not a multiple of 3.
Who said this? 0 is a multiple of every number. 3 into 0 is 0. So C can be 0.
Where I put 10 A plus B plus 3C.
No, C can be 0, it can be 3, it can be 6, 9, 12, and 15 as well, right? Or you can simply write this as, let C be equals to 3 small c, and then rewrite this equation as 3 small c, and then put C equals to 0, 1, 2, 3, 4. And then start forming the equation. A plus B equals to 15. A plus B is equals to 12, 9, 6, 3, and 0. Then calculate the cases individually and then just add them. So we'll get an answer as 51. Everyone clear with the approach? Just some variant where, because there is some constraint, you could not apply the formula directly. Hence, you will get away with the constraint. You will start putting the values of C manually and then try to form the pattern. So when C is 0, A plus B is 15. If A plus B is 15, total number of ways are 15 plus 1 plus sign, because now A can be anything greater than 0, B can be anything greater than 0. So now there is no constraint. So this is nothing but 16C1. This is nothing but 13C1, right? And the last will be what? 1C1, which is 1. So 1 plus 3 plus 5 till, sorry, not this, but yeah, like it's 16 plus 13 plus 10, ऐसा करके till 1. So you just add all of these numbers, you will get 51 as the answer. Okay? But in terms of method, is it clear? How do you solve questions whenever there is any constraint? Okay.